Hi everyone, I'm Soumya, a software engineer and an educator. Welcome to module 1 of the project course. In this one, we will be building an exciting application. Sensors in mobile application. It's very unique, interesting and significant topic. In most of the smartphones that we use, we have hardware and software embedded in it. Like the one which is near the front camera, that is the proximity sensor, and the call app, the default phone app that we have, it uses a proximity sensor to make the screen blank when we pick up the call and we put it in this position, because proximity sensor, the role of it is to check if something is very close to it. It senses if any object or any person, anything is very close to the screen of the phone. In the same way, we have multiple sensors in our mobile phones for temperature, for weather sensing, to detect the motion and so much more. Okay, so today I will pick up one of the sensors, which is magnetometer sensor. Okay, and we will use this to make an application which will be very useful for checking the direction, etc. In most of the smartphones there is that compass app by default as well. So we will try to see how to write the code of sensor and how to kind of embed sensor in our mobile application. Okay, so a bit of theory here, then I will get into developing the application directly. Okay, so sensor overview, let's check the official documentation by the Android developers. So this is by Google Android developers, the official documentation. Okay, so this is overview of sensor. Most of the Android powered devices have built-in sensor which measure motion, orientation and various environmental condition. Okay, these sensors are capable of providing raw data with very high precision and accuracy, and are very useful if you want to monitor three-dimensional device movement, positioning and so much more. So let me give you quickly few more examples of it, how and where sensors are used. You would have seen, like in some of the games, like if you hold the phone like this horizontally, and you perhaps have to move the car in the game, or snake, something like that, and you move it like this, right or left, you would have seen the car or whatever the device is in that game, whatever the object is, it kind of moves along with the screen. So there as well, the concept of sensor is used in most of the gaming apps. Especially sensor is heavily used. Okay, in fitness applications as well, to monitor, to track your number of steps or walk, everything. Like a lot many applications are there actually of sensor, because it's embedded in the mobile application, in the mobile phone, and that's why many of the mobile application use the concept of sensor. So broadly, these are the three types: motion sensor, environmental sensor and position sensor. Okay, so motion sensor is mainly used to measure acceleration forces, rotational forces along the three axes. It include accelerometer, gravity sensor, rotational vector sensor and so much more. And there is a lot of like detail provided here, but don't worry, like I know it might take a lot of time and effort to go through this, and it might be a bit difficult if you're especially a beginner. Okay, so I'll make it all very simple for you, and let's start with building our application. Okay, mostly the concept of sensor will remain kind of same across the different types of, like if let's say you are using environment sensor, or maybe motion position sensor, the basic coding part will remain same. You just will need to change the basic functionality what you want to perform with the help of the sensor. Alright, so I'm opening up Android Studio now. If you don't know, so Android Studio is the software which we use to create Android applications. Okay, alright, so here we will open up, we will create a new project. Sorry, not open up, we will create a new project. I'll pick up the empty activity, which is the default activity. Okay, and here I will write what we are going to create. We are going to create compass. Okay, we are going to use magnetometer sensor to create compass application, which will tell us the exact direction. I mean, if I'm sitting here, so it will help me find east, south, where all the directions are, kind of compass application. Okay, okay, compass application, or you can write magnetometer sensor as well. Magnetometer sensor in here. Perfect. All right, and I'm clicking on finish. Let the project get ready. Some Gradle bells, etc. will happen here. So this is our main activity. Let me close the tip of the day, which is Android Studio provides several content project types. Okay, thank you for the tip. And let's close this one. And let me know meanwhile in the comment section which programming languages do you know. I mean Java, C++, Kotlin, whatever programming languages you are comfortable with. Let me know all of those in the comment section below. And I will start with creating the application now. Okay, perfect. Very first thing what I want to do here is I want a compass kind of image, right? And we know that we kind of put all the images in the drawable directory. So I will right click on this and open in Finder. Okay, so inside the drawable folder, what I want to do, I want to keep one compass image. Okay, so compass image, I already have downloaded that. Let me open up a new Finder window and quickly find it in here. So if I search for compass in here and press enter, so compass, this is the image, right? And I will drag and drop it here in my drawable folder. Perfect. And now I will come here in my XML file. I'll remove this and make this as maybe linear layout. Yeah, let's make it linear layout, and orientation is vertical. Orientation is vertical. This also should be linear layout. Perfect. And after that, what I will do, I'll pick image view in here and I will put compass in this. Okay, looks good. And let's make it in the center. Margin top of 100 dp should work. And just below this, I also want to show you that how you can track the degrees with which the compass is kind of rotating itself. Okay, so text view, drag and drop, and in this text view I will show rotation degree. Okay, and this is your text view, this is image view. Looks good to me. And we can put it in the center. Okay, right, rotation degree. Maybe if you want to increase, you can increase the size of this one a bit. 18 dp. Perfect. And now let's come here in the main activity. Okay, when you are dealing with sensors, the very first thing that you need to do is go in the manifest section. Okay, manifest file, and enter the sensor which you are going to use. So uses feature, then name of the sensor. We are dealing with something related to direction and all, so accelerometers should do the work for us. Accelerometer, and also required true. Okay, that's it. And after that, I'll close the manifest file. Now we have to write the main code. We have added the kind of image view, text view, all these things here as well. And now the most significant thing is to write the code here. So while dealing with sensors, we need to implement an interface, that is your sensor listener, sensor event listener. As soon as you will implement this interface, so if you click on this one, control, once again, command enter. So this is how the sensor event listener looks like. This is written in Java. This is an interface. Okay, and it has two methods: on sensor changed and on accuracy changed. So the on sensor changed, as you can see, it's written here. It is called when the accuracy of the registered sensor has changed. Okay, unlike on sensor changed, this is only called when the accuracy value changes, and you can see the sensor status constant, etc. So basically, if we are implementing the interface sensor event listener, then it is giving us some error here in the main activities. It is saying that class main activity is not abstract, does not implement abstract member. Basically it is asking us that, hey Soumya, like you have implemented this interface, so make sure you implement the members as well of this interface. And we just checked that this interface has two methods, two functions: on sensor changed and on accuracy changed. So I will implement both of these. It's gonna be super simple, don't worry. Like I'll be summarizing all of these steps as well, in case you are thinking that it's very tough. No, not at all, don't worry. Okay, so yes, first thing, in the manifest you have to add which sensor you're going to use. Okay, and then you have to implement the interface here, the sensor event listener, and then the overrided methods will be added here. Perfect. Okay, after that the next step is also, like, I kind of have used sensor, so I know kind of what's the flow, how to go about it. But you can also follow the documentation, the official documentation. They would have given the, step by step guidance as well. Like this one is about the environment sensor, and mostly for all of the sensor the process kind of is similar, but here and there their functionalities differ, right? So it is saying to acquire data from the sensor, you first create an instance of the sensor manager class, and which you can use to get an instance of a physical sensor. Then you register a sensor listener in the on resume method. Okay, so first it is asking me to create one object of sensor manager class. Okay, so I have to do this, that I will be creating an object for sensor manager as well as for sensor class both, and we have to initialize that here in the on create method. Okay, here in the on create method. So what I'm going to do here, I'm going to create two variables. One variable will be of type sensor, okay, and the other variable will be of type sensor manager. Sounds good? Okay, let's do it. Sensor variable of type sensor. Okay, sensor, and I'll give it a null value for now, and to handle null exception, this question mark. Then var sensor manager, this will be of type sensor manager, and this as well will have null value. Perfect. And now is the time that I have to initialize both of this, the sensor manager as well as the sensor. So sensor manager, if you see here, they are telling us that sensor manager can be initialized this way: get system service context dot sensor service as sensor manager. Okay, so get system service context context dot sensor service as manager. Looks good. This is what they have done, and they're saying get an instance of the sensor service and use that to get an instance of a particular sensor. So first we created sensor manager and we initialized it. Okay, we kind of got the instance of the sensor service, and using this we are creating the sensor. If you see here, pressure variable, this is of type sensor. We named the pressure variable as just sensor in our application. Okay, so using the help with the help of sensor manager, we will initialize this variable now. Okay, we will get the sensor which we are going to use. So sensor is equal to sensor manager dot get default sensor, and after that, like, they have used here the pressure sensor. The type here is pressure. So sensor dot type. So in our case, like, you can see there are so many types of sensor, right? You can see there's a huge kind of variety. We can either use accelerometer, it should do the work for us. So for now I will use the accelerometer sensor only. It is throwing some error that add null, non-null as it call. Okay, to handle null exception, etc. And along with this, because I will be using the image here and the text as well. So quickly let's initialize these as well. Okay, where and compass image, this let's make it late in it. Okay, late in it where, because I don't want to initialize it right now. Image view, and in the same way late in it where, and this is your, you can call it text view, or what exactly it will do for us. It will tell us the degree of rotation, I mean how much the compass is rotating. So rotation tv, that is text view of type text view. Perfect. And here quickly let's initialize these as well. You can use view binding, I have already taught in previous videos. If you want to use, that's kind of new and latest, you can use that as well. But we just have two views, so I'm fine using find view by id as well. Rotation tv is equal to find view by id, and r dot id dot the text view. All right, so we are almost done creating the variables and initializing the variables. So how many variables we created for this? Mainly, if you are going to deal with sensors, you have to create two variable, one of type sensor and the other of type sensor manager, and you have to initialize both of them. It's so easy and smooth to initialize them. And let me tell you another thing, while dealing with direction sensor and such stuff, many people kind of prefer using two types of sensor. But in most of the cases, like the accelerometer, or maybe we have to kind of deal with a bit of orientation. So orientation sensor, either of these will do the work for us. Like, yes, either you can use combination of magnet to an accelerator, or orientation, both will work fine. For now let's try with type orientation, and I'm pretty much sure it will work fine with us. I'll quickly run the app once everything is done. So we are in between, kind of we have done the most significant part of it. But if you go here in the documentation, uh, you remember that I said, like, while reading you have to register a sensor listener in the on resume method. So in the on resume method, I have to register a sensor listener, and in on pause method, when the application is paused, then in that case I have to unregister the sensor, so it does not occupy unnecessary space, memory, etc. Okay, so on resume method, with the help of this, we will register as listener for the sensor super dot on resume, because it is overrided function, so it's doing that for calling the constructor, etc. And then we have to register with the help of this code, sensor manager dot register listener, this is the function. And then we have to pass three parameters in here. Okay, and in the same way for on pause method, we have to unregister the sensor when the activity is paused, because we don't want unnecessary consumption of our memory, phone memory, etc. Right? So here sensor manager dot unregister listener, you can either like directly use both the methods from here, or you can write it yourself as well. Either way it's fine. So maybe let's try writing these methods on our own. So if you write here on resume, this is the one, right? And we will write here manager, sensor manager dot register listener. We have to register the listener, because if you want to use the sensor in your application, then you have to register it first, right? So very first thing what we will pass here is, we have to firstly pass the context, then the sensor which we have created the variable, and then the sensor manager dot delay normal. So basically context, and then the sensor which we have created. And after that, in the end, command P, if you do, you have to pass this value, which is sensor manager dot sensor delay. They are using sensor delay normal. Okay, sensor delay, and we will put here sensor delay key, sensor delay UI, and normal. Either is fine. Whoops. So this is done now, and after this I will put null safety character here, and then sensor manager, kind of this step which is registering a listener. This is done. Let's write the comment as well, so it will be kind of easy for us to keep a track of which function is doing what operation. Okay, so register a sensor listener for the sensor. This one is done, and now we will call the on pause method. Here sensor manager dot unregister listener, and you just have to pass here the context. That's it. Cool. So the on resume method and the on pause method both are done. The function of basically on pause method is we are kind of unregistering the sensor. If the activity is paused, we want to unregister it. Perfect. So what all we have done till now, we implemented the interface, and we overrided the two methods of the interface, and then we have two variables here, sensor of type sensor and sensor manager of type sensor manager. We initialize both of this here. Okay, and in this one we are using the orientation sensor. If we don't want to use this, we'll need to use two sensors together for the operation which we are going to do right now, which is a kind of mix of accelerometer and magnetometer. Okay, all right, and the sensor changed, accuracy changed, everything looks good to me. Now the most important function is here. When the sensor is getting changed, let's say if you are using the sensor to track the direction, if the value of the direction, if the rotation is happening, if the value is getting changed, what operation you want to perform? So one thing, I want to create a variable here where current degree. Basically this variable will be of type float, and why I'm creating this, to keep track of rotation of the compass, how much the compass is rotating, the degrees with which, the value with which the compass is rotating. So here we have to understand few things. How can we get the value which the sensor is producing? If there is some change, like let's say this is my phone, and if I'm changing the position, I'm kind of moving here and there, so how will this I know that okay, sensor is doing its role, sensor is kind of performing the action in the background, but how do I get that value in my code here? Because I will be able to perform some action only once I'll get the value from the sensor, right? I mean, if I know that okay, the value is kind of, it's rotated by 70 degrees, so east would be in this direction or that direction, so a bit of mathematics is involved here. And let's write the method on sensor changed. So here the very first thing, I want to grasp the value of the sensor. I mean, if I'm rotating the phone, it would be generating some rotation value, degree something, right? So I will create a variable here var degree, and let me show you how you can get the value. So event, it generates value in form of a array first thing, and we'll get it by accessing the very first index. Okay, let me put here null, and I want to make it round off because the value will be somewhere like in digits, etc. I want to get the round of value, so math dot round, I will use that function. Okay, all right. Now what I have to do, I have the compass image in here, right? This is the image view. So I have to do some animation, I have to perform some animation in this. So compass image dot start animation, right? And in this I have to pass a variable of type animation, right? So I will create a new variable now where animation, okay, or you can say rotation animation, rotation animation, and this one will be I'll use the rotation animation method to write this function. Okay, rotation animation. And if you see here in this, I will be using the fourth type, which it is telling me from degree, from where I want to start to degree. I mean, how much animation, how much rotation I want with this. Okay, so I will start from kind of the initial value 0. I have already created this variable. If you see here, current degree, it is there to keep track of the rotation of the compass only. So I will be starting from 0. Okay, from the current degree. This is the this is the current degree from, and if I do command P, so if you see here, from degrees in float to degrees, how much rotation I want. From 0, I want to go till this value, whatever value the sensor is generating, I want to go till here. Convert this in float to float, and this should be actually negative for the animation to work perfectly. Okay, so minus degree, and this will be in float. Okay, this much is sorted. From degree, I mean initially it's 0, so I will start from 0 degree from to whatever the value this is generating, whatever degrees the sensor is producing. Okay, and what else, if you see here, what value it's asking me for, pivot x type, and then pivot x value, and then again for y the same thing, the type and value. Pivot x type, pivot x value, pivot y type, and pivot y value. It will be same for x and y. Okay, for both the variables we have to use animation dot self, relative to self. This is your type. Okay, and then for the value of pivot x value, let's keep it 0.5f. Okay, and for pivot y type, animation dot relative to self, and same thing for y as well, what we did for x, the same thing for y, 0.5f. Okay, all right, so this much looks good to me. Now I will pass here the rotation animation. Okay, and a few things extra what we can add duration, rotation animation dot duration. What will be the duration of this animation? It can be around something 210 or so. And let's see what other parameters are there. Fill after, fill before. Okay, let's keep it true. All right, so we have degrees to get how much rotation is happening. Okay, and because we have to do some animation in the compass image, so we used compass image dot start animation, and then we pass this variable rotation animation. And for rotation animation, I'm giving all the information to this method. You have to start from current degree, from 0 till whatever the value it is producing. Okay, and then I am passing the values of pivot x and pivot y, basically x and y, the axis, the orientation, it is for all of those. Okay, And duration, I have given it the value 210. You can give it according to your preference. And then we have fill after. So that's pretty much it about the on sensor change method. And one more quick thing, current degrees as well. Like we kind of created it here in the beginning, right? And after every spin animation, or you call it rotation, the value will be changed, right? So I want to update its value as well. It should be equal to this one exactly. It should always be, by the end of this, it should get equal to this value. Okay, to float, sorry. Yep. All right. So that every time, like, I started from 0, I did the animation till here, then again I have to start from here now. So from degrees should be equal to the last value. Okay, it's a bit of mathematics. I'll get into the iPad to explain, but let's first check if the application is working fine. Let me see if I'm missing something. So for sensor, we added the sensor event listener, and we have the two methods, overrided methods. Because of that interface, we have two variables. We initialized both of them. It looks good to me. And okay, another thing, in this text rotation TV, I didn't add the value, right? So rotation TV dot set text is equal to degree. Show the degrees, right? Degree dot to string plus degrees, something like this. Okay. So it now looks perfect to me. Let's run in the app, in the phone, in the smartphone, and check if it's working. So in the emulator, it might not work very well. So I'll bring my phone now and then we'll run. So I've connected the smartphone, the Android phone here. I will click on run and the application is getting prepared. Let me go in the project. I think I'll need to make one change that in the module section. Let's change the compile SDK and target SDK to 34. It's making the same complaint, sync now. And after that, build is successful. And I will go in here. This is the smartphone. Okay, I've connected it and we are running it via Visor. This is the phone. I hope you can see the app screen. Okay, so we'll click on install now. Install. And this is the compass app. As you can see, if I'm rotating it, right, like this, so exactly like east, for me east is this one, this is north. It's telling me the correct direction. And degrees as well, as you can see, it's changing so fastly. 340 degree, 58 degree. If we go here in the, in our Android Studio as well, and in the log cat, I think we have not logged that. You can check the values, the rapidly changing values, by logging as well. Like if you go in here, the you can do something like log d and press enter. And here you can ask for the values of, maybe just write degree here. Okay, I want to keep track of the values which are getting changed here. And for that, we need to do option enter. That's it. Once again, perfect. All right, so this is how the app looks like. It's blank right now. So I think it's working completely fine. Okay, the application is all good and set. So I hope you got a bit of idea like how to go about it, how to write the code of sensors. Okay, we used one sensor in this one. I will try to cover different types of. So as you can see, like the orientation sensor, it worked for us, right? Or we could have used a combination of two sensor as well. but this one is fine. And in manifest you just need to write the sensor name which you are using. So I hope the concept is clear. Let's quickly get into the iPad where I'll be explaining quickly like what the summary, what all we did. Okay, so the very first thing, we need to implement this interface sensor event listener, right? And with the help of this, we got two methods, two overrided method, that is on sensor changed and on accuracy changed, right? So that is the first thing. And then we have to create two variables, sensor and sensor manager, of type sensor and sensor manager, right? And we initialized both of this here, like with the help of get system service method, and then sensor, with the help of sensor manager we initialized sensor. Perfect. These were the images etc that we used. Then in on resume method we have to register a listener for the sensor. It's very simple. And then in on pause we have to unregister the sensor with the help of unregister listener method. And the most significant one is on sensor changed method, where we performed all the operation what we have to do. We basically wanted to run animation, right? So compass image dot start animation, and this is the value of the animation. Now this part is very important. It's all about kind of mathematics. We got the value from the sensor, like whatever is the change in the degrees and the rotation direction everything, we got the value with the help of this event. This is the event dot values dot get, and at zeroth index, every time in all type of sensor you will get the value in form of arrays, and at the first like zeroth index you will get the values. Okay, whatever the sensor, whatever value the sensor is producing, you will get all of that in the first index, which is like zeroth index mathematically, technically, right? Perfect. And we did round off of this value. So math dot round, this is the degree with which the kind of phone or the sensor is feeling that okay, the sensor is sensing that this much rotation is happening. So after that we showed the same thing in the text view. And this is the rotation animation. We created the variable with the help of rotation animation method, in which we said from this degree to this degree this much rotation will happen, and we pass the value for pivot x and pivot y. Okay, and we added duration etc for the animation, and we also updated the value of current degree variable which we created in the beginning every time. Okay, every time. So this is the on sensor changed method. You can take a screenshot of this if you want, and this is the complete code that we wrote for the compass application. And apart from that, we also have to write the name of the sensor which we are using in the manifest file. So yes, let me know in the comment section below if the concept is very clear to you. Maybe just write understood or completed the project or understood the concept whatsoever. Just keep me posted how you are feeling about all of this tutorial, and tell me which tutorial you want to see next. I hope you liked the tutorial. If yes, make sure you hit the like button and subscribe to our channel for more such insightful content.